Hello my dear students, welcome to HD Physics classes. Myself Akash HD, and today we are going to start the class with a digital board, is it? I hope so. Now onwards you can understand and learn the class in much more better way, is it? Because we'll be having the multiple colors and all, so the classes will be more interactive and more learning and more fun. Okay, so students, today we are going to learn the topic focal length of lens, and here which lens we are going to use? We are going to use the biconvex lens. What do you mean by the biconvex lens? That means the radius of curvature of both the lenses will be what? It will be different. So here also you can see that here I have taken one convex lens, and that is the biconvex lens. Here I have drawn with the two colors, one with the white color, that will be the first surface, and second one with the red color, and it will be the second surface. That's why the name is what? Biconvex lens. Why? Because radius of curvature of both the lenses is what? Same. Okay, so now what we are going to do, we are going to find out the relation between focal length and the radius of curvature of the lenses. Okay, so dear students, you can see here the lens is there. This is the first surface here. Now let's take for example this one I have taken. This is surface A. Now, so if we imagine one sphere will be which side? Sphere will be right side. Okay, so see here please, here I can write here, this is the center of curvature of the first surface. Okay, now if we talk about the second one, for second one the surface will be which side? The surface will be left side. This sphere will be left side. That means center of curvature will be which side here? The center of curvature will be left side here. Okay, so let me draw here. This is the, I have drawn here C2. Okay, and again I'm telling, this is the first surface, this is second surface. This surface I am giving the name here, this is P. Okay, now what we are going to do here, we are just going to do the refraction first from surface A and then from surface B. Now this is the surface B. Now here students, this is called the optical center of the lens. Now this is what? This is the optical center. All the distances we will measure from here. Okay, now students, you know very well, we have learned the refraction through the curved surface. What was the formula? Do you remember? Refraction through the curved surface. No? Refraction through the curved surface here. Okay, so see here please, here for refraction through the curved surface we know very well, as we know that, yes, guess the formula please. The formula is mu2 by v minus mu1 by u is equal to mu2 minus mu1 by r. This is the formula of refraction through which one? Curved surface or the spherical surface. We have done the derivation also. If you want to learn this derivation, just click on the I button. Okay, so now what we are going to do here, we are going to take one point object. I am going to take one point object here. This is the point object I have taken here. This is the point object O. Now just one thing here, this thing we will just remove this C2. This C2 will write down, so that what will happen, we can get the proper diagram. And one more thing we'll do here, this A also. Now because here we have to just draw the rays and all. No, so see here please, this is the A is there. Now this is better. So now what will happen here, we have to do the refraction from the first surface. So first what we have to do, we have to draw the normal, and normal should pass from where? The normal should pass from this center of curvature. Okay, so see here please, here I will just draw the dotted line here. See, now this is the normal N1. Okay, now what will happen that here from the object one ray will start. Now like this here, the ray will go like this here. Now and this ray it will meet here, and after that what will happen that here, as the ray is going from which medium to which medium, here I have taken, let's take this medium is mu m, and this side also it is the mu m, and this lens, let's take, I have taken for lens I have taken mu l. Now what will happen that here, as the ray is traveling from where to where? Rarer to denser medium, then what will happen that here, it will bend towards the normal. Okay, so here please, here it will bend towards the normal. Let me draw here like this. Now and like this it will go, and its image will form here I1. And how much distance here? If we see from here, now this distance, this distance how much, students? This distance I have taken v1. Okay, and at the same time just do for the object also. This object how much distance? The object is having the u distance. Okay, so what will happen that now we are going to use this formula for the surface A. Okay, so let's see here please, for surface A, let me change the color here. Now for surface A, so see here please, here for surface A. Again, mu1 is the medium from which light is coming and mu2 is the medium to which light is going here. So you can see here the light is coming from mu m and going into the mu l. So what we can write here? We can write here this mu1 is a mu m and this mu2 is a mu l. This thing we are going to use here, and the radius of curvature of the first surface, how much? R1. Okay, this distance, this radius of curvature is what? R1. So let's use in this formula. Hence what we can write here? See here, please here. We can write here, see, mu l by v1. Now the distance of the image from the optical center minus mu m by u is equal to mu l minus mu m by r1. Okay, so this one will make it equation 1. Now our equation 1 is ready. We have seen the reflection from which surface? We have seen the reflection from the surface A. Now what will happen that the image that we have got reflection from the surface A, this image will work as an object when the refraction will happen at which surface? It will happen at second surface here. Okay, so what will happen that here after that we'll get the, see here please, this here. Now the refraction we have to do at this surface. This is which surface? Surface B, and the center of curvature is where? This side here. So now we have to draw the normal, new normal here. Okay, so here please, this is a normal now, this is a normal, and 2. And now what is happening? The ray is traveling from the lens to the medium, normally air. So what will happen now? It will go away from the normal here. Okay, so let me draw here. Like this it will go here. No? And here the final image will form. Okay, and let's see that here the distance of final image from the optical center, how much? This I have taken V. Okay, so what will happen that now let me draw for the surface B. Now we are going to see the refraction from which surface? Surface B. Okay, so now here please, the light is coming from which medium? Lens. That means here what will write here? This mu1 will be mu l. Light is going into which medium? This one here, air or mu m. So what will be the mu2? The mu2 will be mu m. And the radius of curvature, how much? This one. The radius of curvature this side here. This is the radius of curvature. What we can write here? R2. Okay, so again we are going to use this formula. Now, so what will happen that here? Let's use the formula here, students. So what will write here? What is mu2? The mu2 is mu m. So let me write here mu m. Image is forming where? The image is forming at a distance of v. So mu m by v minus mu l. And what I told you, this image will work as an object for refraction at surface B. So we'll write here mu l by v1 is equal to, again this will become here mu m minus mu l by r2. Why? Because mu2 is mu m and mu1 is mu l. This formula here. Okay, so this one will make it equation 2. Okay, now students, our equations are ready. This equation we have got when the reflection from first surface, and this one we have got when the reflection from the second surface. Now what we'll do? We are going to add both these equations. Okay, so let me write here adding equation 1 and 2. So just guess please, when we add both the equations, what will happen that here? See please here, this mu l by v1 and mu l by v1 both will cancel out. That means we'll be left with, see here please, mu m by v minus here mu m by v minus mu m by v, this one here, and here mu m by u is equal to, here students, just here please, this will become here mu l minus mu m, and here it will become here 1 by r1 minus 1 by r2. Now we'll simplify this more. You can see very well here mu m is common, that mu m will go which side? Right side. So I can write here what? I can write here 1 by v minus 1 by u is equal to mu l minus mu m by mu m. So if you simplify this, it will become here mu l by mu m minus 1, and here what is this? 1 by r1 minus 1 by r2. Okay, what is this? This is the refractive index of lens with respect to medium. And what is this? 1 by v minus 1 by u? That is the lens formula. For that also we have done the derivation. What was the derivation? 1 by f equal to 1 by v minus 1 by u. If that derivation also you want to learn, just click on the I button. Okay, so 1 by v minus 1 by u will become what? 1 by f. So here we are going to write here just finally this one, 1 by f equal to this mu L with respect to m minus 1. Okay, just 1 minute. Minus 1, and here what is this? 1 by R1 minus 1 by R2. So students, we have got this formula. What is this formula? This is the formula, the relation between focal length and the radius of curvature. Okay, so students, here we have taken the biconvex lens. Sometimes, okay, derivation is completed, but sometimes what will happen in the question, it will be equi-convex lens or plano-convex lens. Now, so for that I will just tell you sign convention and directly we will use this formula. Okay, so I hope so all these things are very clear to you. Now we are going to just learn plano-convex lens and equi-convex lens formula. Okay, so what will happen that here, students? Just see that here. Now, what derivation we have done? We have done the derivation, as you know very well, as we have got, what we have got? 1 by f equal to mu lens with respect to medium minus 1, and here 1 by r1 minus 1 by r2. Now what I am talking about here? First one, I am going to talk about the equi-convex lens. What do you mean by the equi-convex lens, students? Equi-convex lens, that means what will be there? The radius of curvature for both the lens will be what? Same. Let me draw here. See here, please. This is the equi-convex lens. Okay, so see here, please, like this here. Now, this is the first surface, this is the second surface. All the distances we have to measure from the optical center here. So for the first surface, what will be there? Sphere which side? This side. That means this is the R1 for the first surface, and for the second surface, R2 will be this side. Okay, so for equi-convex lens, what will be there? This R1 will be plus R and this R2 will be minus R. With sign convention, I have taken this side plus and the opposite side I have taken minus. Okay, so if we use this formula, what will get here? Hence, see here please, 1 by f equal to, I am just writing mu minus 1, and here 1 by R minus 1 by minus R. This minus will become plus. So students, when we write here, we can get here f equal to, after solving, r by 2 mu minus 1. This formula we have to use for which lens? Equi-convex lens. Okay, one more, because from here numericals used to come. Now second one please, if I talk about here plano-convex lens. Plano-convex lens. Plano-convex lens. Plano-convex lens, how? It may be like this also. Now, so first we'll see this one here. This is the first surface. This is which surface? Second surface. So see here please, here. This is the here. All the distances we have to measure from here. First surface means radius of curvature. How much? Please tell me. R1. Flat surface means radius of curvature infinite here. And second surface R2. R2, guess please, plus or minus R? See, for second surface the radius will be this side. Okay, radius will be this side here. And for the sign convention, what is the R2? R2 is going to be minus R. Now again, we will use in this formula. Now what will happen there? Just guess please here. Hence, 1 by f equal to, again, mu minus 1. And here, R1 value how much? R1 value how much? Infinite. Minus 1 by minus R. Okay, so if we write here the final value, so hence this focal length will come r by mu minus 1. So this is the focal length of which one? Focal length of the plano-convex lens. See here, equi-convex lens, I have used f. So plano-convex lens, okay, I will just use f dash here. Even I am telling that, see here please here. Even plano-convex lens we have not drawn like this. It is given even like this also. Let's take for example in a question. It is given like this. This is the first surface. This is the second surface. Then what will be there here? Tell me please here. This is the center of curvature. And R will be this side here. So what will happen for the first surface? R1 is plus R. R2 is infinite. Do you think the formula will change? Formula will not change. Formula will be what? As it is same only here. Okay, see here please here again. Extra 1 by f dash equal to mu minus 1. 1 by R1 is how much? R1 is R minus 1 by infinite. Okay, so you can see here please. What is coming? The formula is same or different? Same formula. R by mu minus 1. Okay, and if we see that here, how many times it is compared to the equi-convex lens? So R by 2 mu minus 1. So what we can do here, see please, I can multiply with that, I can divide with the 2 and I can multiply with the 2. So it can become here how much? 2f. So what we understood, the focal length of the plano-convex lens is twice of the focal length of equi-convex lens. Same concept we use for the lens cutting also. Okay. So in lens cutting, what happens that they will give one equi-convex lens is there, focal length is f. Focal length is f. Now what we are going to do, we are going to cut this lens into how many parts? 2 parts. One part is this and one part is this. Now, so students, what will happen that in this situation, you can see here focal length is f. So here focal length will be how much? When we will cut the equi-convex lens, how many lenses will form? The 2 lenses will form. Both are which lens? Both are plano-convex lens. So here focal length how much? Here focal length will be 2f. And here also focal length will be how much? 2f. This is called the which cutting? This is called the transverse cutting. Similarly, if we cut the lens horizontal, so horizontally what will happen that when we are cutting the lens horizontally, second case, then what will happen that the material is not going to change, mu will not change, radius of curvature will also not change. So radius of curvature will not change, and after that mu is also not changing. So what will happen? The focal length will not change. So what I am telling that, dear students, in today's class, what we have learned, first we have learned the focal length relation with the radius of curvature of the biconvex lenses. Then after that we have done for equi-convex lens also, and we have done for plano-convex lens also. And at the end what we have done, we have just learned the concept of lens cutting also. Transverse cutting means focal length twice. If we cut the lens horizontally, then focal length will not change. Okay. So students, I hope so that today's class you have learned very well, because we have used the different colors also. Okay. So if you understood this class very well, this setup and all, you are liking a lot. So just share to your friends this video and just kindly subscribe to my channel and keep learning and keep learning. Okay. Because that will only make your career very bright. Okay. Thank you so much.